chain project management. This will be a very brief overview of critical chain. Let's start by understanding how it's traditionally done. What are the current problems with traditional critical path technology? Here's a typical project, but most of us have multiple projects going on at any one point in time. So let's say there are 9 other projects going on at the same time as this one shown here. So now we have 10 projects. You can see project 1, project 2, and it continues all the way down to project 10. Let's start by understanding how task durations are typically determined. It's different, of course, for each organization, but often the task duration is determined by asking the task resource, how long will it take you to do this task? For some organizations, the task durations are based on history, but initially somebody had to answer the question or make the first guess of how long will it take to do this task. If you were asked this question, would you give the answer that was a 50% chance you could finish in the project in the promised time, or something greater? Now, most of us want to give a high probability answer because we like to meet our commitments, which means we give the about 100% probability of completing the task in the time given. So if we draw a normal distribution, and of course this isn't exactly normal, but let's, for convenience sake, say it's a normal distribution, that means that we're giving the 100% far to the right of the normal distribution chance of getting it done in that time. With a 100% probability of completing each task, we should finish projects on time, right? Well, not necessarily, due to a couple things. First of all, you've probably heard of student syndrome. Remember when you had that test, but it wasn't for 2 weeks? We didn't necessarily start studying for it right away. We don't always start a task right away either. And each resource is typically working on several projects concurrently. So while we might have 10 projects going on, a particular resource could be involved in many or all of those projects. So here I've added resource A in red, where you can see resource A at least is involved in 3 of the projects that we can see. So let's talk about multitasking. Let's say that resource A starts working on project 1, but then gets a call from the project 2 manager and asks them to please start because the customer has just called. Now, doesn't this sound familiar? What happens many times is resources end up having to bounce from task to task, rarely being allowed to focus on just one. So between student syndrome, not starting right away, and this bad multitasking, it is quite possible for a 100% probability task to still be late. But doesn't it all average out? You would certainly think that while some tasks are late, others must finish early, and we should have a shot at finishing the project on time. That sounds logical, and you would certainly think that would be possible. But unfortunately, that's not how it works. If you are one of the task resources who finish early, you typically don't pass it on because either the next step in the project may not be ready for it, or you may be expected to finish in that amount of time next time, so you're reluctant to hand it off early. And by the way, there's always some improvements you can do. So Parkinson's law, since you have a little more time, you tend to spend the time. So the net of this is that only lateness gets passed on, and early completion simply does not. That's why projects are perfect. By perfect, I mean 100% late. Most companies who do projects are either less than 100% on time, or they go through extraordinary measures to meet their commitments. You might even see some of the people wearing capes. Signs of extraordinary measures include overtime, worn-out staff, poor morale. It's easy to recognize. So if that's the problem, what's the solution? Now we'll introduce critical chain project management. And again, this will be a very brief introduction, but to give you a sense of what it is and how it works. First, we put the buffer where we need it, Instead of buffering each task, let's put the buffer where it's needed. If each task has a 100% probability that we'll complete in that time, we can cut each task in half and use the buffers. What essentially we're doing by putting the 100% probability in a task, we're buffering each task. So what we're going to do is cut each task and then use the buffers at the end of the project. So here we're cutting each task of our original project in half. So what was 10 days becomes 5, what was 7 becomes 3.5. Where we used to finish at the end of the project, if we were lucky, and most likely it was well beyond that if we were perfect and late like most environments, we're now going to be able to finish in much less time by cutting the task in half. So what we do is we take the time that we save by cutting each task in half, and half of that time that we cut now becomes a project buffer. So if we can finish within the project buffer duration, you can see we're already finishing projects faster. The rule of thumb is that the project buffer is 1/2 of what you cut from all the individual tasks. Second, we consider resource contention in determining the critical chain. The critical chain is the critical path, which is the longest chain of dependent events, with the addition of resource contention. We also put feeding buffers at connection points along. So here we've identified the critical path and critical chain, which in this example happen to be the same. The longest chain of dependent events is this top box here, and it also happens to be the critical chain. We put a buffer for the project buffer as we did in the last step, and now we're adding a feeding buffer because the set of tasks below that connects into the critical chain, we want to make sure that it doesn't cause a delay on the critical chain itself. Next, we also take into account resource contention across all projects, which means that we stagger the start of projects so that our constraint resources are not working on any more than one task at a time. So if resource A is our constraint resource, we stagger our project starts accordingly. So back to our list of projects, we can see that project 1 starts and offset by 5 days because that's the time it takes resource A to do project 1. We're starting project 2, and then 8.5 days after that we can start project 10 here, which takes an additional 5. So we're staggering according to this resource A, which in our example happened to be the constraint resource. We also want to change our measures. We have to let everyone know that we understand there is only a 50% chance that we will finish their task on time. It is okay if they go over, and that's what the buffers are there for. And it's now easy to track projects. We can track task completion relative to project buffer penetration. We can then easily determine which project is most at risk for being late and respond accordingly. And finally, we can now focus our continuous improvement. If we take the project buffer and divide it into 3 equal zones, a green, a yellow, and a red, we can track reasons for penetration into the red zone. We Pareto those reasons then to guide our continuous improvement and to really focus those efforts. So that's a very quick, very brief overview of critical chain project management, and of course a very simple example. No doubt much simpler compared to your environment and what you have to deal with. So you may want some more information. Here's some recommended reading. Critical Chain is Dr. Goldrat's business novel. It's written very similar to The Goal. It's a very easy read, very entertaining. The challenge is that it's hard to understand how to apply those concepts to your business. So I also recommend a companion ebook called Projects in Less Time. And those two things together I think will be a very good next step. You can get those from me for a reduced price of $25, which includes shipping, if you just send an email. And of course, if you'd like to implement Critical Chain in your organization, feel free.